Okay, so you want some more examples on how to go from degrees to radians. Now this will help you with page 348 in your book, that assignment. So let me give you an example. The directions are to change from degrees to radians, and as we discussed in class, there's a formula, there's a unit converter that will change, let's say for instance 225 degrees, and I want to change that into radians in terms of pi. So we already determined that pi and 180 equal each other. Pi is the same thing as 180 degrees. Okay? We'll need to remember that. If these are the same thing, then if I put this over this or this over this, then I've created the whole number 1. I can multiply the whole number 1 times anything and it does not change my original number. So I'm going to multiply times a funny form of the number 1. The funny form of the number 1 is going to be either pi over 180 or 180 over pi. Now, how do I know which one I'm going to use? Well, this is 225 degrees over 1. If I multiply by another fraction, if I'm changing from degrees to radians in terms of pi, then that means I want the degrees to go away. The only way for degrees to go away is for me to have degrees at the top and degrees at the bottom across the multiplication sign in order for me to cancel them. So I'm going to have 180 degrees down here and pi here. Now, I multiply this fraction times this fraction, and you know that I'm able to cross-reduce. So I'm going to cross-reduce first. I'm going to cross-reduce the symbols or the units. We always cross-reduce even the words when we're cross-reducing. So in my handy calculator, I can pull out that and find that this reduces to 5 over 4 there. So this 225 degrees ends up being 5 pi over 4 radians. So what we did was we canceled out the degree symbol. There was nothing with which to cancel the pi symbol, therefore it stayed. And there's our answer. Okay, let's do another example. 330 degrees. We're going to multiply by a funny form of the number 1. We want to cancel the degrees, so we're going to let degrees be on the bottom. I cross-reduce across the multiplication, and I end up with, that goes, this ends up being 11, this ends up being 6, and I have 11 pi over 6 radians. All right, there you go. So you say, well, that's fine, but what if I have to go from radians to degrees? Let's take a look at an example of radians converted to degrees. Let's say I have 7 pi over 4. It's kind of rattling there, isn't it? And I want to convert that to degrees. We remember that 180 is equal to pi. They're the same thing. If I want to convert this and I want to make this go away and I want to introduce a degree symbol, doesn't that imply that when I multiply by the funny form of the number 1, I'll need the pi at the bottom and I'll need the 180 with the degrees at the top. Now we know that the pi's are going to cancel out. There's the cross-reducing there. I'm actually going to cross-reduce my numbers here. 4 goes into 4 once. 4 goes into 180. What is that, 45 times? Now, you notice there's no degree symbol here to cancel with this degree symbol. Therefore, the degree symbol is not going to go away. All right, so 7 times 45 with my handy little calculator gives me 315, and my degree symbol is still there. All I have on the bottom here are 1s. Therefore, I'm finished. There's the answer. 7 pi over 4 is the same thing as 315 degrees. Now, let's try another one that's kind of different. And I believe this is actually an example. Oh, let's see just a second here. It's an example from, sorry about that, an example from page A36. This is from A36. Okay. On A36 they have some, when we're going from radians to degrees, and there's no pi symbol at all. Okay, no pi. In fact, they have just some plain old numbers, and they say change from radians to degrees. For instance, they might give you just a plain old decimal like this, something like that. Well, they still expect you to know that this is radians, even though I don't see a pi. If I don't see a pi and they say go from radians to degrees, that means that the pi is hidden in there. We can't see it, but it's in there, which means they've already multiplied the number times the pi. So I'm just knowing, and I just need to know that there's a pi already there. Therefore, I'm going to multiply by the funny form of the number 1, and I'm going to get the pi out of that. Now, how do I get the pi out of that if I don't have it there? I'll just go ahead and multiply this times this and divide by pi with my calculator. So I go ahead, now in the directions it does say to round to the 10th, so I pay very close attention to what it says to do. This is requiring us to round because the pi is in there. So if I multiply this times this and then divide by pi, I get 544.3 degrees if I round it to the tenths. So this is how to do it when you're not given a pi. We understand that it's already in there. Okie doke? Okay, one last example. There's a few problems on your last part of your assignment that deal with this type of thing. And it asks you to find a trig value for some of these radians. So, my recommendation would be the first thing to do, my recommendation would be to go ahead and change this back to degrees. That's something with which you're more familiar. So, I'm going to take 7 pi over 6, since you're proficient at this now, of course, and change it back to degrees. Okay, that changes back into 210 degrees after I do my canceling. 6 goes in there 1 time, 6 goes in there 30 times, 7 times 30 is 210. That means this question is actually asking, what is the sine of 210 degrees? That's the question. What I can do very easily is to give myself a quick little unit circle and put my terminal side at 210 degrees, which is actually about right there, 210 degrees. And then if you notice that 210 leaves me a reference angle of 30 degrees. If this is 30 degrees, then I know exactly how to get to that dot. I know the actual distance here and here, so if I name that dot in terms of the coordinates, I'm going to go negative square root of 3 over 2, and then I'm going to go negative 1/2 in order to get to that dot, because I know that this is my unit circle. This is a 1, this is a 1/2 over here, and this is the square root of 3 over 2 here. So, it becomes very simple at this point. What is the sine of 210 degrees? Basically just means what is the sine of this triangle. The sine of that triangle is, with respect to this reference angle, opposite over hypotenuse, or in other words, the sine is this right here, negative 1/2. Very simple. This quadrant sine is negative, that's why it's negative. And there you go.